Today, factors and products is a unit that's really important. I would say it's, to me, probably the most important unit of the course. And also to me, it is a huge indication of whether students should go into 20-1 or 20-2, is how well they do with this unit. Okay, so this unit in particular, the first, it's kind of broken up into two halves, or maybe not halves, but the first part of it is all numbers. Okay, so there's a bunch of numbers, and we're looking at different things using numbers. Then, when we get to the second part of the unit, it's way more algebraic, and there's a bunch of stuff. Algebraic means not numbers, right? We're using x's and y's and other letters, okay, to symbolize variables. Okay, so there's two parts to it. Now, the first part, so today and maybe tomorrow, the first couple days are going to be, or not tomorrow, tomorrow. Grade 10 retreats next week. Okay, so today and tomorrow, it'll be pretty straightforward, probably. Okay, we're going to have just a lot of number stuff that can be done sort of like by procedure, and it's really simple. Most people will find it nice and easy. Then when we get to next week, and we really get into this unit, you're going to find that it's significantly harder. Okay, it's a lot harder than trig was. I don't want to scare people, but I want you to be here and to be taking it seriously and to practice. Because this unit is like way harder than trig. Okay, like way harder. And factoring, in particular, is a skill that is super important. Okay, like a couple of years ago, the math department, they had us, so all the math teachers all together, we had to decide what we thought we should make a lesson on together. And the question was sort of, what's the most important thing from grade 8 to 12? What's the most important thing that we need to get better at teaching? And the answer we came up with was factoring. That's how important it is. And we decided it was the most important skill from grade 8 to 12. And I really think it is. If you finish this unit and you can't factor, there's going to be people in the room who finish it without being able to because it's hard. That, to me, is a huge indication that you should go into 20-2. So if you're aiming for 20-1, not that there's anything wrong with 20-2, but in 20-1, you have to factor constantly. It's like a daily thing. So if you can't do it, the course is almost impossible. Okay? So if you get to the end of this unit and you can't factor, you need to, and you want to take 20-1, you really need to come to some tutorials and start practicing with me. Okay? It's not that bad. There is a procedure to follow. Like, I think pretty much anyone's capable of it if they're willing to practice. It's not like you have to be a genius to do it. It's just, for some people, it's going to take a lot of practice. And if you're not willing to practice, you're going to find it really hard. Okay, so, but today, bright news, because I know that sounds scary. The bright side is that there are parts of this unit that are really easy. That's what we're going to do today. And that stuff's going to be on the test as well. So you can get the points, even if you're struggling with the other stuff, the points for this easy stuff will be nice. And you can get them and you can probably still scrape by. Okay, so here, what we're going to be looking at is factors and multiples of whole numbers. And this is kind of stuff you've sort of seen before for the most part. Some of it will be a little bit new, but it's mostly stuff you would have seen in middle school, at least to some extent. Okay, so it's pretty nice and easy. I like this stuff just because I like easy things. I'm sure everybody does, right? It's nice when math makes sense. Okay, so here, we're going to talk about a few different things. We're going to be talking about prime factors, which is like two words that sometimes students don't know what either one of them means. So does anyone know what a prime number is? A prime number. Could anyone just tell me a prime number? Cynthia? 7 is a prime number. That's good. Okay. Anyone have another one? 3 is a prime number. They're not odd numbers, although most of them are. 5 is 1. 11 is 1. 9 is not 1. So why would, we just listed a whole bunch of them. So we listed 3, 5, 7, 11, which kind of just looks like the odd numbers, but I'm telling you 9 isn't 1. So if 9 isn't 1, but all those other numbers are, why might that be?
3 times 3 is 9.
Because it's divisible by 3. That's right. Is that what you were going to say, Cynthia? No? Okay, so a prime number, the actual definition of a prime number is that it's a number that can only be divided by 1 and itself. Okay, that's the definition of a prime number. So for instance, 3 can only be divided by 1 and 3. Okay, those are the only things that go into 3. So it's prime. 2 is also prime. So the prime numbers are like 2, 3, 5, 7, 11, 13, 15 isn't 1. After 2, there's no more even numbers. How come after 2 there's no more even numbers?
Because the rest can be divided by 2.
Yeah, because the rest can be divided by 2, at the very least, right? So 13, 15 isn't 1 because it's divisible by 5. 16's even, so it's not 1. 17, though, is only divisible by 1 in itself, so 17 goes there. What about 19? Yep, 19's good. Okay, nothing goes into 19. What about 21? Nope, because 7 goes into it. 3 and 7 go into it. 23, though, is good. Okay, and it goes on. Okay, when I was little, there was we had really old computers. I mean, at the time they weren't that old, but you can imagine like the old school computers. And there was a game called Prime Munchers. It was like a little dude, and you had to walk around and like eat all the prime numbers. So kids were great at prime numbers because they played that game all the time. It was like a huge thing. So everyone knew their primes up to like 200 because of that game. But now it seems like that game doesn't exist anymore when kids are little. People didn't even know what prime numbers were. Like you'd have grade 4 students who could list all the primes up to 200, but they didn't know what it was. They just had them memorized. Okay, so that was the good old days. Now 1 is not a prime number. That's just a rule. 1 is not a prime number. 1 is just its own thing. Okay? So we don't include 1 in the list. But it doesn't matter. You're not going to be asked that specifically. But it's really important because what we're going to be looking at here is prime factors. So these numbers are the ones we're going to be using as prime factors. You don't need to memorize them or anything. Although knowing them up to like 13 or 17 would probably be helpful because you're going to be using them a lot. But I don't want you to sit down and try to memorize them. Okay. Now this stuff is like kind of all up here at once, which is not usually the way I do it. But a factor, okay, is a number that divides evenly into another number. So that's what a factor is. Okay, so people tend to get factors and multiples mixed up. Okay, factor is a number that goes into the number you're looking at. So 12, if I'm talking about the factors of 12, it's all the numbers that go into 12. And you've probably seen before when you were younger, sort of like a factor rainbow kind of thing. Usually teachers do that at some point. So if I'm talking about 12, right, 1 and 12, okay, and you put them on either side, and you can kind of think, okay, together they make 12. Okay, then 2, what does 2 pair with? 6, so 2 and 6 are both factors, and 3 and 4 are factors. Okay, and they make this little rainbow-looking thing. Okay, these numbers are the factors of 12. Okay, now what we're going to be concerning ourselves with are the prime factors of 12. Okay, so the ones of the factors that are prime numbers. So if I look at all these numbers and I say, well, which ones are prime? Which of those numbers are prime? 2 and 3, not 12, because 12 is divisible by a whole bunch of numbers. Okay, it's okay. Okay, and what we're going to be working on is writing the prime factorization. So every number that isn't prime, and I guess prime's 2 in a way, but every number that isn't prime can be written as what we call a product of primes, okay, which sounds really complicated. But what it means is a bunch of primes multiplied together. So for instance, with 12, if I go 2 times 2 times 3, what does that equal? 12, right? This, 2 times 2 times 3, is called a prime factorization. Because factorization just means turning it into a multiplication statement. Okay, we're going to look at a method for actually doing these. And you could write this out as 2 squared times 3 instead. That's usually how it looks, because it's a little bit shorter. Okay, if I had, especially once the number's getting bigger, 12 is easy because it's short. But if I had a number like 1,000, right, and I had like 2 times 2 times 2 times 2 times 2, it's a lot easier to write that as like 2 to the power of 4 or 2 to the power of 5 or whatever it is. Okay, so that's called a prime factorization. So the only numbers that are allowed in a prime factorization are primes. So I couldn't put a 4 in there. I can't change 2 squared into 4, even though 2 squared is 4. Okay, so let's look at kind of the method. It also says here, just so you know, if you see the word, I won't test on definitions or anything, but it says up at the top there, at the top of my screen right now, a number that isn't prime is called a composite. That's for everything except for 1. 1 is neither prime nor composite. Okay, it's its own special thing. But all other numbers, so like 2 is prime, 3 is prime, 4 is composite, 5 is prime, 6 is composite, 7 is prime, 8 is composite. Okay, they're just opposites of each other. Okay. Let's look at the method. The method is, there's 2 methods. I do them both. Usually I have students who like both of them. Okay, so like some students like the first method, some students like the second method. I'll never make you do one method or the other. You can always pick. Okay, so if you prefer the tree method, that's the way I personally prefer, okay, then you can always use it. If you prefer repeated division, there's always students who do. I'm always shocked by it because I think it sucks. But there's always people who like it and do it. Okay, if you like that, that's great. Do it all the time. Okay, I just think it's, personally, I think it's harder, but there's always students who think it's much easier. The repeated division. I like the tree. Okay, so I'll show you the tree first. So if we're starting with a number like 3,300, that's a really big number. I know, I'm not going to pretend it's not. Okay, so we've got a big number there, 3,300. What you're going to do is, if you're doing the tree method, you start with 3,300 up top. Oops. Try to be neat about it. Start with 3,300 up top, and what you need to come up with is you need to come up with 2 numbers that multiply together to give you 3,300. Can anyone think of 2 numbers that would multiply together to give me 3,300? 33 times 100. It's 33 times 100 would be an obvious one, I think. So look at them logically, right? If it ends in 10, if it ends in a 0, it's divisible by 10. If it ends in 2 zeros, it's divisible by 100. So that makes it a little bit faster. You could also, there's no wrong answer here. As long as the 2 numbers you pick multiply to 3,300, it's going to work. So I could just divide it by 2. Like I could go 2 times 1650. Okay, I could do that and keep going that way. And that would work. But I'm going to use the 33 and the 100. If you do pick higher numbers, it's faster. Okay, so if you go for higher numbers, it goes a little bit faster. But you could just keep going by 2s each time if you wanted to, like until you can't do 2s anymore, and then you could move up to 3. Okay, whatever works. Now, 33, then I do the same thing with these new 2 numbers. 3 and 11. Yep, you were right. You had it, and somebody at the back had it too. Okay, so 33 and 11 make 33. It's multiplication. That's what I'm thinking here. And once I get to a prime number, like 3 or 11, those are both primes, I stop and I circle them. Okay, because I couldn't do another tree for that, right? There's no 2 numbers that make 3 except 1 and 3. So I'm not going to do it again. Now with 100, what makes 100? 10 and 10 is kind of an obvious one. Okay, you could do something else though. You could do 50 and 2. There's no, again, there's not like a wrong and a right. Okay, and then 10, what multiplies to 10? 5 and 2. 5 and 2, 5 and 2. And those are prime. So I circle them. And then we multiply them all together. So what I do is I'm like, okay, I start with the lowest one. So there's 2 2s. So I write 2 squared. Ooh. 2 squared. There's 2 5s, so I write 5 squared. And there's a 3. Oh, we skipped 3 actually. And you should go in order. So 2 squared times 3 times 5 squared times 11. Okay, so that's all the numbers. And how can I tell if I did it right?
It should give you 33.
It should give you 3,300. So if I type that into my calculator, if I go ahead and I go 2 squared times 3 times 5 squared times 11, as long as I did it right, I get 3,300. Okay, so it's not too bad, right? That's pretty easy. You just make your little tree. We're going to practice it right away, so it'll be fun. Okay, now repeated division. I think the reason that people like it is because it is like a really pretty clear process that you follow and you just do the same thing every time. Like some people don't like coming up with those numbers, like having to say, well, 3,300, that's 33 and 100, like coming up with that. Some people don't like it. So repeated division's easy. The way you use it is you start with 3,300, you start with your number, and you divide it by 2. Okay, so just always 2. You start with 2. If 2 doesn't work, you go with 3. If 3 doesn't work, you go to 5. If 5 doesn't work, you go to 7. Only primes. Okay, you only use prime numbers. Okay, so 33 divided by 2, just like Hannah said earlier, is 1650. And that's even, so I can divide by 2 again. So what I do is I take that number again, and I divide it by 2 again. I divide 1650 by 2. And I get 825. Okay, now 825 is not divisible by 2. I know that because it's not even, but you could try it if you're not sure. I go divide by 2 and it gives me a decimal, so it doesn't work. So I try 3. 3 works. So I go 825. So you don't jump numbers. Don't go up to 5. Like I know 825 is divisible by 5, but you just keep going in order. So it gives you 275. Then I check, is that divisible by 3? It's not. So I move up to 5. So 275 divided by 5 is 55. That is also divisible by 5. So I do 55 divided by 5. I get 11. And that's a prime number. Once you get to a prime number, you stop. Okay? Now these, including that 11, are your answer. Okay? So I have 2 squared, because there's 2 of them, times 3, times 5 squared, times 11. So you see I get the same thing. Okay, and I say I do like the tree. I think it's faster. But this has a nice smoothness to it, where they're all in order already. They're all given to you exactly the way you want them, so they're kind of nice. Okay, there is something kind of nice about that. Okay, so I do get why some people prefer it. Okay, guys. Okay, so everybody look up here again. Okay. Oh, I guess I didn't print this off for you, these notes. I will print them off for you. Okay, today it's not so bad because there's not too much writing in terms of the questions, but I will print them off for you so that you can if you'd like to keep notes in the slideshow. Okay, I forgot, to be honest with you. So here we are getting to the next 2 things, which are also pretty straightforward. Okay, and there are kind of like methods to doing this that I could teach you, but to be honest, I've taught this course a number of times now, and the methods tend to just kind of confuse people. Better than that is probably just doing it the old simple way, which is the way I would have done it if I was actually given these questions. So there's 2 things that we're going to be looking at, is the greatest common factor and the lowest common multiple. Okay, there's 2 things. So greatest common factor, if we're talking about that factor, remember factor means a number that divides into another number. So for 12, it's 1, 2, 3, 4, 6, 12. Okay, those are the factors. Okay, for bigger numbers like this, 138, 198, they're going to have a lot more factors. Okay, it's going to be kind of a long list. Now, when we're trying to find the greatest common factor, that means the highest number, because greatest means highest, the highest number that divides into both of them. Okay, now some people are very good at this and can kind of just look at numbers and come up with it. If the numbers are low, it's easy. Like if I'm talking about 12 and 30, I can look at that and say it's 6, because 6 goes into both 12 and 30, and nothing else works. Okay, 12 doesn't work. I can do that. But if they're big numbers like this, 138 and 198, really what you should probably be doing is just making a list. And it's a little tedious, but it's the fastest and way that doesn't tend to mix anyone up. So 138, if I make a list for 138, okay, it's nice kind of to do the list like what we did with 12, where we do that little rainbow thing. You don't necessarily need to draw the rainbow, but to fill it in, you can actually, the other way to do it is always to list pairs. So I often do it like that. Like I'll show you what that would look like. So if I'm like, well, 1 and 38, right? 1 and 138, because that's always one of them. So 1 and 138 make 138, right? Obviously. Okay, now 138 is also going to be divisible by 2. So I just keep going. I'm like 1 works, 2 works. So if I do 2, I get 69, I think, right? Okay, then 69, I'm like, well, that's not going to be divisible by 2, but it will be divisible by 3. Yeah, so it's going to be divisible by 3 here. Actually, I guess I'm not even thinking about 69, but I kind of do think about it a little bit. Okay, so, guys, so 138 and 3, if I think about it, it's 46. Somebody said that. I'm sorry, I just didn't hear you completely. Okay, so 46 works. Now I go 138 divided by 4. It gives me a decimal. If it gives me a decimal, I don't write it down because that didn't work. Yeah, I know 5 isn't going to work. So I try 6. So 6 and 23. Now if you don't, when I say I know 5 won't work, if you don't know 5 won't work, just try it. You don't have to, if you have good number sense, it'll make it a little easier. But you can just try every single number. You can just start at 2, 1, do 1, 2, 3, 4, 5, all the way down. Yeah, I try 7. 7 doesn't work. I try 8. 8 doesn't work. I try 9. 9 doesn't work. 10 definitely won't work. I don't think 11 will work, but I try it anyway. 138 divided by 12. Now, once I get to 12, okay, the answer it gives me, when I do 138 divided by 12, I get 11.5. Once this number is lower than this number, you can stop. Okay? Nothing else is going to work. So you know there's an ending. It's when the two numbers meet. Okay? Like in the rainbow, right? Like with 3 and 4, how they met each other in the rainbow. Here we're meeting the middle of our rainbow here. So we can stop and move on. Okay? So then I do the same thing, and I know it's a little tedious because that took, a few minutes. Okay? But then I do the same thing with 198. So if I do it with 198, I know it's 1 times 198. Okay, 2 times, it'll be 99. Thank you. Okay, feels like I should have known that. Okay, 3 looks like it's going to work, so I go 198 divided by 3, gives me 66. 198 divided by 4, doesn't work. 5 won't work. 6 works, I get 6 and 33. Okay, I do 7. 7 doesn't work. I do 8. 8 doesn't work. I do 9. 9 works. I bet that's probably going to be the last one, but I just keep trying just in case. Divided by 11. Oh, 11 worked. See, so it's good I kept going. 11 and 18. Okay, try 12. 12 doesn't work. 13 doesn't work, and I'm getting very close to meeting here. 14 and 14 don't work, so I can stop. Yeah, 18 works because it's already there, right? I have 11 and 18. Yeah, we're going backwards then. So once you start, like that's what I mean, like once you get down to here and we're moving back up, stop. Because you're just going to keep going. You could go forever, right? We can continue back down all the way to 198 again. Okay, now, when I want the greatest common factor, once I get these lists, yeah, it's kind of a pain in the butt to get these lists, especially if the numbers are exceptionally high. But all you're looking for is the greatest common one. So that means the highest number that's on both lists. So it looks like it's 6, yeah. Okay, so 6 is the greatest common factor. So here the answer is 6. And that's it. So it's a little tedious, but it's not hard. Okay, and there's a difference between those things, right? It takes a couple minutes, but it's really just a matter of divide, 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 divide until you find it. So you might have to do a little bit of writing. If you know the answer, if you're given one where you just know the answer, feel free to just write the answer down. Okay, but most of the time I might check, because sometimes I get students who are like, oh, I knew the answer was 4, but actually the answer was 8. Right? They just thought they knew. So being careful with that. Okay, and we are going to look at as well, oh yeah, we got lots of time. Okay, at multiples. Okay, so a multiple is actually the opposite of a factor. I would say one of the biggest things in this unit is students just mixing them up, like not remembering which is which. That's just on you. You've got to memorize it. Okay, so factors are the numbers that go into a number. Multiples are the opposite of that. Okay, so the multiples of 12, for if we were talking about 12, right, the factors were 1, 2, 3, 4, 6, 12. The multiples would be 12, 24, 36, 48. It's the counting up by. Okay, yeah, you just keep counting up by it. So here are the this shouldn't say factors. Ugh, God, even I mix it up. This should say multiples. How many times have I used this slideshow and I haven't fixed it? Okay, the multiples of 13 are 13, 26, 39, 52, 65, 78. So you just keep counting up by 13. Okay, it's easy enough. You just keep adding 13. So for two or more natural numbers, which just mean whole numbers, we can figure out their lowest common multiple. So it's different, right? Greatest common factor, lowest common multiple. With multiples, we're looking for the lowest, but it's actually pretty much exactly the same, other than the fact that we are not looking at factors, we're looking at multiples, and we're looking for the lowest. So you make your lists the same way. Okay, so if I have 18, 20, and 30, now I have three numbers given to me. Kind of a pain. Okay, there's three of them. So what I do is I just make a list. And this one's a little harder because you don't necessarily know where to stop the list. Like the list keeps going forever, right? So you don't want to make the list way longer than you have to. It kind of depends how you do it. I might start with 30 and just work with 30 and check. So if I start with 30, okay, 30 is the first multiple of 30. What would be the next multiple of 30? 60. Now, sometimes I only make one list and I just check the numbers. So, well, actually, here, I'll show you what I mean afterwards. Let's just do it all the way out. 30, 60, 90, 120, right? Okay. Okay, now, we can keep going, 150, you can keep going. Now, if I do the same thing with 18, okay, 18, the next one is 36. Okay, then I add another 18. Use your calculator, right? There's no heroes here. You don't want to make silly mistakes just from trying to add 18 over and over again. Okay, the next one's 54. Then it's 72. Okay, then it's 80, 90. Oh, 90 seems to work for both of them so far, right? Does it work for 20 as well? No. So that one's not good enough. We're going to have to keep going. Okay. So if I keep going from 90, I get 108, 126, 144. Okay, and you can see this list is going to have to keep going for a while. And I would make sure I'm not making any silly mistakes. I'm not so far. I was hoping maybe I'd made a mistake. So I keep adding. It's 162. Okay, that's going to be 180. Oh, 180 is going to work as well. Now, is 180 divisible by 20?
Yes.
Yes. So my answer here is 180. So you notice I didn't even have to make a list for 20s. Like I didn't make a list. I just asked myself, once I got to two of them working, would the third one work as well? Okay, and asking myself that question. In fact, you could only make one list if you wanted. Like I could have made only this list. I usually use the highest one if I'm just going to use one list. So 30 because it's the highest. Yeah, I make the one list, and I just check each number. So I'm like, 30 is not divisible by 20. Like, some of them I can just cancel off. Like, I know 30 is not going to work, 90 is not going to work, 150 is not going to work, because 20 doesn't go into them. And then I check the other ones to see if 18 would go in. So I would try it out. 60 divided by 18 doesn't work. 120 divided by 18 doesn't work, but 180 does. Okay? And so that would be a little bit faster. But you can straight up just write all three lists and look for the lowest number that's on all three, if you want. Okay, there's more than one right way. As long as you get the right answer here, I'm happy. Okay, that's what I want. I want the correct answer at the end of the problem. Okay, so it's a little bit different than